Hello everyone, welcome back to our Microservices Masterclass. In the previous video, we learned what microservices are, how a microservices architecture works. But there is one important question we haven't answered yet. How do we decide when one microservice ends and another one starts? Should we create user service or not? How do we decide? Should I create order service or not? How do we decide, right? Should I combine payment or order service together or make it separate? How should we decide? It should have some principle, right? This is the exactly problem that domain driven design help us to solve. So in this video we'll understand domain driven design from scratch using the infographics what you are seeing on my screen currently, and by end of this session you will understand what is domain driven design, why it exists, strategic design, tactical design, bounded context, context mapping, ubiquitous language, entities, value objects, aggregates, domain events, how domain driven design help us to design a better microservices, right? So stay tuned, let's begin. Let's start with the first question itself. What is domain driven design? Domain driven design is not a framework. One thing is very clear. It is not a programming language and it is not a software architecture as well. Then it is a way of thinking about the software. What is a domain driven design? It is a way of thinking about the software. It tells us that software should be designed around the business problem, not around the database, not around the UI screen, or not around the programming languages. It should be designed around the business problems. The word domain simply means business. What are we trying to solve, right? For example, a banking application belongs to a banking domain. E-commerce application belongs to a retail domain. Hospital management belongs to a healthcare domain. Food delivery app belongs to a food delivery domain, right? So what domain driven design says, understand the business first. Rather than understanding technology and this and that, you have to understand the business first. Only then start writing the code. That's the core philosophy of the domain driven design. We need to understand the business first. Right, now let's move to the strategic design. You can see the second point in the diagram, right? The strategic design help us to divide large business into the smaller business areas. Like if you have a bigger business, how we can divide that into smaller parts, smaller business areas. Let's imagine we are building an Amazon application. Amazon does not have one responsibility. It manages customers, products, orders, payments, inventories, shipping, notification, and so many things. So instead of building one giant application, DDD divides the business into the bounded context. Instead of building a one giant application, domain driven design divides this business into the bounded context. What is the bounded context? A bounded context is a clear boundary where a particular business model and terminology are valid. For example से समझते हैं. Let's say customer context, right? Product context, order context, payment context, inventory context, shipping context, notification context. Each context has its own rules, data, and terminology. Later, each bounded context often became its own microservice. Getting the point? One big business domain, it's divided into the different subsections like customer, product, order, payment, inventory, and different context. And each and every context can be transferred to a one microservice architecture. This is why domain-driven design and microservice works so well together. Now let's understand what is the context mapping, right? Although every bounded context is independent, they still need to communicate. For example, the order context need customer information. The payment context need order details. The shipping context wait for the successful payment. The notification context send email after shipping. The context map documents these relationship. The context mapping है, it does mappings, establish a relationship between these context. It answers questions like which service communicate, what data do they exchange, which service on the data, which service depend on another. Without context map, large system become confusing very quickly. Fine, you got the what is context mapping? Now let's move to the next point. What is tactical design? Okay, these tactical design are the building blocks that developers use while writing the code. Let's understand each one. Entity. An entity is an object with a unique identity. Entity is an object with unique identity. Even if its property change, it is still same object. For example, a customer, a product, order, an employee. Suppose a customer change their address, they are still same customer because their customer ID hasn't changed. Identity makes an entity unique, right? Next is the value object. Value object has no identity. It is defined entirely by its value. For example, address, money, email, coordinates, currency. If two money objects both represent 500, right, they are considered equal. Value objects are usually immutable. Value objects are usually immutable. Once created, they don't change, right? The next one is aggregate. An aggregate is a group of related objects treated as a one consistency boundary, right? Every aggregate has an aggregate root. Let's understand with example. The order is the aggregate root. Inside it we have order item, shipping address, payment information, total order. Instead of modifying child object directly, everything goes through the aggregate root. This protects business rules and keeps data consistent. The next one is the repository. Repository hides the database operations. Instead of writing SQL queries everywhere, the application asks the repository to save and retrieve aggregates. Think of a repository as a bridge between the business logic and database. Correct? Next one is domain service. Some business operations don't naturally belong to one entity. For example, price calculation, discount engine, tax calculation, currency conversion. These belongs to the domain service, right? It does not belong to one entity. The next one is the domain event. Whenever something important happens in your business, we create a domain event. Example, order created, payment completed, inventory reserved, shipping delivered. These events can trigger actions in other bounded context. Correct? If one event completed their job and they triggered one domain event, right? That event can be consumed by another bounded context and they can process based on behalf on that. Correct? Now look at the comparison on the left side, point number 4. Many beginners design service around technical layers. For example, order controller, order repository, order database, payment table, customer table. This creates tightly coupled system. Domain driven design teaches us to design around business capabilities, right? Instead of technical layer, we create customer service, product service, order service, payment service, inventory service, shipping service, notification service, and each service represent one business capabilities. This produces loosely coupled, highly cohesive microservices. Okay, now let's move to the next point. Ubiquitous language. What is ubiquitous language? Let's try to understand with example. Business experts and developers often use different words. For example, the business team says reserve inventory. Developer says update inventory table. The business team says order shipped. Developer says status equals 4. This creates confusion. Domain driven design encourages everyone to use the same language. Developer, architect, business analyst, product owner, everyone speaks the same business terminology. This improves the communication and reduces the misunderstanding. Okay, that is known as the ubiquitous language, a shared language between the developer and domain expert. For example, right? Now let's see the benefit of domain driven design. It aligns software with the business goal. It improves communication between the technical and business teams. It reduces unnecessary complexity. It creates clean service boundaries. It makes application easier to maintain. It supports a scalable microservice architecture. It encourages high cohesion and loose coupling. Got it? Now let's see the challenges. See, domain driven design is powerful, but it is not that simple as well. It requires deep understanding of the business domain. Finding the right bounded context takes time. It requires continuous collaboration with domain expert. It applies incorrect if it applied incorrectly, we may create too many services or boundaries that don't reflect the businesses. That's why domain driven design is most valuable for the large and complex business domain. Okay? How does it help to design a microservice? Let's see the complete flow diagram. First, understand the business domain. Next, identify the bounded context. Then, define the common ubiquitous language. Design the aggregates, business rules within each context. Map each bounded context to an independent microservices. Define communication between services using APIs or events. Ensure each service on its own data. And finally, deploy and scale each service independently. This is how successful companies design large scale systems. Let's quickly recap today's session. We learned that domain driven design is a way of designing software around business problems. We explored strategic design, and tactical design. We understand bounded context, context map, entities, value objects, aggregates, repositories, domain service, domain events. Most importantly, we learned that domain driven design help us to discover the right microservice boundaries. Remember this one sentence. Microservice tell us how to build distributed system. Domain driven design help us to decide what those microservices should be. In the next lesson, we will dive into the service design and service boundaries, where we will learn how to decide the right size of a microservice, avoid common design mistakes, and create a scalable, maintainable architecture. Thank you for watching. If you found this video helpful, please like, share, and subscribe. See you in the next lesson. Till then, take care. Bye bye.